called as an AI application lifecycle. When most of us think of data science, the first thing that usually comes to mind is Jupyter notebook hoga. There'll be some kind of a Jupyter notebook. Somebody will write some code and then cells will be executing it. And then most of the people who are experienced, they would definitely have an understanding that this is not the case. We want to deploy them into production. And by production, really put it to use. So if you think about it, AI is practically all around us. If you take out your phone, look at Amazon, look at Flipkart, look at Netflix, you have all those amazing examples of recommendation systems, right? These systems, they have captured AI beautifully. And as you keep watching, let's say a certain type of series on Netflix, it's going to recommend you more content. And there's AI working behind the scenes. If you see video conferencing tools these days, there's a lot of interesting background change option. Like my video currently is blurred, right? That's AI. This is what is usually understood as an AI, which is eventually consumed. I am consuming an AI. Behind it is still a model, which was probably coded in one of the many programming languages that data science supports, be it Python. Yes, that is the most popular one. I did hear somebody talk about JavaScript. Yes, TensorFlow Lite exists. You can do all sorts of cool stuff if you're operating in browser. So TF Lite for has JavaScript. There is also programming languages like R, which are yes thought on the heavy on the side on statistics and core. But yeah, you could do just fancy stuff in R. There's a good application called Shiny, which can help you deploy things in R. And then there's new age applications like Julia, which is coming, which is further taking computational aspects of AI to the edge. If you don't like any of these, you can do core C, C++. A lot of these libraries, like I think Srijan was mentioning, is available in multiple languages. And for example, you can write C plus code and you can use Tensor. So in totality, there's plethora of languages, but the idea remains the same. How do we make sure that an AI, which is effectively a model, is consumed? And that's pretty much the goal for this slide or for the next few minutes that I'm going to be okay. So I'm just going to start with this application flow, and the idea is we call this as an AI application lifecycle. Why lifecycle? Because it starts with data, you deploy it, and then it iterates. It's a loop. It's a whole cyclic process. That's what gives it the word lifecycle. So the first thing that you do is you prepare something, right? You have some sort of a data which is coming from different sources. And when we say data comes from different sources, it is variety. Most of the times, again, the difference between a real world project and a learning project or a POC is data is not equivalent to pd.read CSV or pd.read Excel, which is pretty much what we do when we use pandas and read data. It is usually coming in the form of some live form, be it a database, be it a system, be it a source of data, for example, a Twitter stream and things like that. It could be a video feed, it could be news articles, variety of sources. And the idea is you go through these steps to prepare your data. A lot can happen when we say prepare, things like ETL, which is extract, transform, load, or ELT, which is extract, load, transform, data pipelines. Those sort of concepts are typically looked here when we say prepare the data. The output almost always is some data set has a meaning in the given context. So for example, if I'm making a Netflix recommender system, there could be thousands of data sets. However, the core data set is the output, right? Which is where this line shines in. And then the idea is to do this whole exercise enough number of times that you get some kind of a model. Now, this is the exercise which is usually tagged to data scientists who do modeling, because the term data scientist is extremely convoluted in the industry. People like lead data scientists, like people who I work with, they are great modelers. They have great understanding of data and functional domain and whatnot. And they also apply and understand deployments and cloud and all of that. So I would think they are all architects, but yeah, their designations are data scientists for whatsoever reasons. So data science typically is taught here, which is usually thought as the cool stuff. But if you talk to any data scientist, they will tell you that almost 60% of the time goes in the prepare phase where you're cleaning the data, massaging the data, doing feature engineering, applying all sorts of transformations. And that's very important. So if you are somebody who's fascinated by the modeling aspect of an AI, key model banaya and some predictions happen, please make sure you learn how to work with data, how to do EDA, because those are the sorts of things that are typically in interviews. Okay. Then what we do is we have something like a Jupyter Notebook or a Visual Studio Code where we write code. Now these are environments where you operate with data, call new libraries, generate. This happens enough number of times, and something which is loosely called as a model is saved. And why I say loosely is this can change, this can evolve over time, right? But let's say you got a best model right now. That's the model you want to deploy for. So you will take that and register your model. And when we say register your model, there's a concept of model registry in ML ops, which is a very hot topic these days. But in general, it is just saying save your artifact. People who have been good old Java developers, they know this is like a jar or the deployable version of the file. This is an artifact pretty much. This is a serialized file. Okay. And then comes the fun part, which is usually where I operate mostly in. And this is where you ship your machine learning model. One of the most common ways to do that is packaging in the form of a Flask API, where you have Flask application. You have, let's say, code like import Flask, import Pandas, import Skykit. Then you get the data from the REST API that Flask provides. You get the data, you apply those transformations, and on those vectors, you do a model dot. Where do you do model dot predict? Model is already saved, and you have that serialized. Now, this Flask application can be happily containerized, which is to say, if you're familiar with Docker containers and things like that's what this containerization process will do. And then finally, once you deploy it, there'll be some sort of an endpoint which could be listed as a web service. So you could have a REST endpoint. Let's say we come up with an image and say that what's really the type of this. So it's a dog or a cat or in the type of the dog. So I gave it like a Labrador image, and the URL would be like slash predict category of the animal, and then the path to the image, and then path would be sent to the application. Flask would read that image. Flask would then give the data to Skykit, would do the prediction, say it is a dog of type Labrador, and send as a JSON response. So the understanding of this whole life cycle is extremely important. Once you deploy it, you got to monitor it. Like how many times did I give a false classification? How many times did I give a not successful error? How many times did my API fail? How many times did I give an authentication error? So that's the core idea of an AI application lifecycle.